Concept of electromotive force EMF of a cell. Electron flows from anode to cathode in external circuit due to the pushing effect called or electromotive force EMF. EMF is called as the cell potential. Unit of EMF of cell is volt. EMF of cell may be calculated as E cell is equal to reduction potential of cathode minus reduction potential of anode. Similarly, a standard EMF of the cell E naught may be calculated as E naught cell is equal to a standard reduction potential of cathode minus a standard Nernst equations. Walter Nernst derived a relation between cell potential and concentrations or the reaction quotient del G is equal to del G naught plus RT in Q, where del G and del G naught are free energy and a standard free energy change Q is reaction quotient minus del G is equal to NFE and minus del G naught is equal to NFE naught. Thus, from equations 1, we get minus NFE is equal to minus NFE naught plus RT in Q. At 25 degrees Celsius above equations may be written as E is equal to E naught minus 0.0591 upon N log Q, where N represents number of moles of electrons involved in the process. E and E naught are the EMF and a standard EMF of the cell respectively. In general, for a redox cell reactions involving the transference of n electrons AA plus BB to CC plus DD, the EMF can be calculated as E cell is equal to E naught cell minus 0.0591 upon n log C to power C D to power D upon A to power A B to power B. Equilibrium constant from Nernst equation. E cell is equal to 0. E naught cell is equal to 2.303 RT upon NF log Kc. Heat of reactions inside the cell. Let n Faraday charge flows out of a cell of EMF, then minus del G is equal to NFE. Gives Helmholtz equations from thermodynamics may be given as del G is equal to del H plus T in bracket del D del G upon del TP. From equations 1 and 2, we have minus NFE is equal to del H plus T in bracket del minus NFE upon del TP is equal to del H minus NFT in bracket del E upon del TP. Del H is equal to minus NFE plus NFT del E upon del TP. Entropy change inside the cell. We know that G is equal to H minus Ts or del G is equal to del H minus T del S, where del G is equal to free energy change, del G is equal to enthalpy change, and del S is equal to entropy change. According to Gibbs Helmholtz equations, del G is equal to del H plus T in bracket D del G upon dt P. From equations 1 and 2, we have minus T del S is equal to T in bracket del D del G upon dt P. Del S is equal to minus D del G upon dt P. Del S is equal to NF in bracket D E upon dt P. Concentration cell. The cells in which the electrical current is produced due to the transport of a substance from higher to lower concentrations. Concentrations gradient may rise either in electrode material or in electrolyte. Thus, there are the two types of concentration cell: electrode gas concentration cell, PT, H2 P1, H plus C, H2 P2, PT. Here hydrogen gas is bubbled at two different partial pressure at electrode dipped in the solutions of same electrolyte. Cell process. L upon 2 H2 P1 H plus C plus E minus anode process. H plus C plus E minus 2 I upon 2 H2 P2 I upon 2 H2 P1 equilibrium 1 upon 2 H2 P2. E is equal to minus 2.303 RT upon F log P2 upon P1 1 upon 2. E is equal to in bracket 2.303 RT upon 2F log P2 upon P1. At 25 degrees Celsius, E is equal to 0.059 upon 2F log P1 upon P2 for a spontaneity of such cell reactions P1 greater than P2. From Nernst equations, we have E is equal to 0 minus 2.303 RT upon 2F log C1 upon C2. E is equal to 2.303 RT upon 2F log C2 upon C1 for a spontaneity of such cell reaction C2 greater than C1. Electrolysis, the decompositions of electrolyte solutions by passage of electric current resulting into depositions of metals or liberations of gases at electrodes is known as the electrolysis. electrolytic cell. This cell converts electrical energy into chemical energy. The entire assembly except that of the external battery is known as the electrolytic cell. Anode positive, cathode negative, electrolytic cell.